In this video, we're going to continue on with section 4.5, which is solving inequalities that involve quadratic functions or equations, and there's really nothing new to add here. I just want to give two more examples and then give you another your turn. Okay, so each one has its own unique flair of things that we need to look at and care about, but overall we're using the same general principles of how to solve for the problem. Okay, so let's solve the inequality x squared minus 3x minus 10 is greater than 0. So again, we look, this is because there's a positive in front of the positive 1 in front of the x squared. This is concave up. Okay, so we know it opens up. The vertex happens at, we have A, B, and C. Vertex happens at negative B over 2A, so it happens at 3/2. And then we substitute 3/2 into the function x squared minus 3x minus 10. Okay. So when we do that, when you substitute 3/2 in here, again, I'm going to go quicker than I did the last time just because we've had some familiarity with the process, so I'm not going to explain everything that I did previously. But certainly if you need me to, we can go over that in class. So 3/2 squared is 9/4 minus 9/2 minus 10. Okay, so we can rewrite that as 9/4 minus 18/4 minus 40/4. And so we get negative 49 over 4. Okay, and so the vertex is there, 3/2 and negative 49/4. Great. Now to get a picture, again, I'm going to erase some of this work over here. I'll make my picture now. Okay. So 3/2, negative 49/4 is the vertex, and negative 49/4 is just a little bit over negative 12. So we've got 3/2, which is 1.5, negative 12. Negative 1, negative 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So hopefully that's 12 there. So it starts there, or so, okay, and then it goes upwards, so we're going to have something like this. The difference between this inequality and the other one is that we're not interested in what's below x, we're now interested in what's above x. Okay, so we're going to find the x-intercepts again. I don't care about the y because it's not really going to help us. So if we find our x-intercepts, it is setting the function / equation equal to 0 and solving. Okay, so what x's make this equation true, make this equality true, that we can factor. And so we need two things that add to negative 3 and multiply to negative 10. That's fairly easy, negative 5 and positive 2. Okay, and so the solutions are 5 and negative 2. Those correspond to the points 5, 0 and negative 2, 0. So it happens at 5, 0 here, okay, and negative 2, 0, which is right here. So if we draw that, at least the approximate shape here, to redo my lines, we think it's somewhere around here, okay, and it's going to go up like that. Oh, not like that. Okay, not great, but good enough for our purposes. What we're interested in is when that's greater than 0. So it's actually these points up through here. Okay, not the lower half. Okay, so the answer to this, okay, is really two parts. So it's when x is less than -2. Okay, remember this is a strict inequality here of greater than, so we're not including the points. So it starts all the way up to when x is -2. Okay, then that stops and we go below 0, and then it starts again. Say or when x is greater than 5. Okay, so that's when we do that. To write that as an interval notation, we'd say less than -2 is from -infinity to -2, and then the or looks like this. It's a big U. Some people call it a cup. It looks like a big U, okay, or uppercase U. It looks like a cup. And so it's -infinity to -2 with a cup. That means or 5 to infinity. Okay? So those two. Okay, so that's that one. Let's try one more. 4x squared plus 9 is less than 6x. So we first have to get everything on the left side. So we get 4x squared minus 6x plus 9. Okay. And so is less than 0. Okay. Now, 4x squared minus 6x plus 9 is a special function here, okay? Oh, so there are many ways that we can go about this, okay? You can go about the quadratic formula way, and that might be the best way, but you'll see here, actually, never mind. Let's do it the quadratic formula way, since that's known to be the easiest. Okay. There might be a nice way that you can factor this, and certainly if you see it, you can, okay, but I don't want to make anyone confused. So a quadratic formula is negative b, which is negative of -6, 6 plus or minus the square root of 6 squared, negative 6 squared, minus 4 times 4 times 9. Okay, so there's that all over 2a, 2 times 4. Okay, so actually this may be interesting here, okay, because we have 6 plus or minus the square root of negative 6 squared is 36, but we have negative 4 times a times c, and that's 4 times 4, which is 16, okay, times 9, and 16 times 9 is a large number, okay, and so, let me calculate, 16 times 9, Sorry, 16 times 9 is 144. 144 divided by 8. Okay. 36 minus 144 is a negative number. So 6 plus or minus, let's see, it's negative 112. I believe. Sorry, negative 108. Negative 108 divided by 8. I cannot have a negative number in here. I can't have a negative number under the square root sign. That's going to give me an imaginary number, and so not necessarily what I want. And we can't work with that in this class. So there are no, I left out some context here, or at least writing it down I left out some context. I jumped right to trying to find the x-intercept, okay, because it's the important part. Okay? So I tried to find the x-intercept here, okay, and when we do that, I do that by setting it equal to 0, okay. So this is really x equals, and it turns out we can't do that. So there are no real solutions to our x-intercept, to our methods in which we find the x-intercept. So there's no real things that happen. But what we could do, though, is we could try to substitute some numbers into our equation here to try to draw it. Okay, so let's do that. I'm drawing the xy intercept here. It might be, in fact, too small for us to get it. So, if we substitute in 0, we get 9, okay, 0, 9, so that's here, okay. So that's the y-intercept, so we found the y-intercept. Let's write down things that we know. Y-intercept was 0, 9, okay, and actually, this gives us enough information because if you look here, the coefficient in front of the largest term is positive, and so that is concave up. Concave up. And so I have a function here that starts at 0, 9 and goes up. Hence why there are no x-intercepts, because it never crosses the x-axis. So the answer to when is this this function here, I'll circle it in red, when is this less than 0? It's never less than 0. Never less than 0. There are no solutions to this equation. Okay, so this was a bit of a tricky one. But we found the y-intercept, and we found that it was concave up, so we know that it's never less than 0. Hence, why there are no solutions. So, with that, these skills in mind, I want you to try to solve this last one. Okay, x squared plus 8x. When is that greater than or equal to 0? Okay, that's the end of section 4.5, okay, and the end of the material for section 4.5.